Hello everyone, welcome to Deeksha Karnataka YouTube channel, and currently you are watching Sankalp KCET 2026 batch. Here we are discussing each and every chapter's theory, and then we are also discussing the previous year questions for KCET as well as JEE. So I have completed the first chapter, electric charges and field theory portion. Now today I am going to discuss the PYQs for KCET. So it will be KCET PYQs, and in our next class we will be discussing PYQs for JEE as well. So those who are waiting for JEE PYQs, don't worry, we will cover that as well, and it will be done for all subject physics, chemistry and maths. For biology there is no JEE, so for biology we will be covering KCET PYQs, right? So let's start with session, but before going into the session, just have a look of our achievers from KCET 2025 batch. And these students, as you can see, they are all studied from us from our YouTube channel only, and there are a lot of names of them. We have already discussed their names multiple times. Now why I am showing it to you, because next year in 2026, if you are studying from us and if you are putting your attention properly, okay, without skipping the lecture, without just going through it just because you wanted to go through it, but if you pay attention to our lectures and learn and discuss the problems with us, then definitely your picture will be here in case after KCET 2026 is over. I can guarantee that. Now let's start with the paper. This is first few questions obviously from KCET 2025 papers. So those who have seen that paper may have tried to solve it but may not be able to solve all the questions. So here is a question from electric charges and field from the year 2025. A metallic sphere of radius r carrying a charge small q is kept at a certain distance from another metallic sphere of radius r by 4 carrying a charge small q, capital Q. What is the electric flux at any point inside the metallic sphere of radius capital R due to the sphere of radius r by 2? R by 4. So here we have two spheres, one of radius capital R, charge small q. Here we have another sphere of radius r by 4 and charge capital Q. Now they asked you what is the electric flux inside the sphere. What is the electric flux inside the sphere due to this charged sphere? Now as you can see that this charged sphere is outside the larger sphere. It is not inside, it is outside the larger sphere. So from Gauss's law we can write that phi is equals to Q enclosed by epsilon naught. Now none of these charges are part of this Q enclosed. So none of them are Q enclosed means what is that? Q enclosed is basically 0. In fact, it is a charge sphere, all the charges residing on the surface. So no matter whether you are considering the due to small sphere or due to any charges inside the sphere, there are no charges inside. So definitely Q enclosed is 0. So that means flask will be obviously 0. So flask will be obviously 0, no doubt about it. So correct answer is 0. So this is the level of question in KCET, right? You expect most of the questions to be almost easier and you can solve it like instantaneously. Now let's see another question. Here it's a similar question, again two sphere, and again it is from 2025 only, but the orientation is different, the charges are different. You are given a dipole of charge plus q and minus q separated by a distance 2r. So here minus q plus q separated by a distance 2r. A sphere of A of radius r. A sphere A, this is the sphere A. If you can see, this is the sphere A of radius r, so the radius is r, okay, passes through the center of the dipole as shown. So it is passing through the center of the dipole as shown. That means the minus q is located at the center of this sphere, okay. Another sphere of B of radius 2r. So this is the sphere B of radius 2r passes through the charge plus q. So this is passing through the charge plus q, okay. Then the electric flux through the sphere A. So here we are trying to find the electric flux through sphere A. Electric flux through sphere A. So again our favorite thing, Gauss law, phi equals to q enclosed by epsilon naught. So what is the q enclosed for sphere A? Q enclosed is minus q, okay. It will be minus q by epsilon naught. So it will be minus q by epsilon naught. So option 3 is correct. Now remember that if both dipole, plus and minus, if we construct a sphere combining the entire dipole inside this sphere, then what will be the flux? I'll not answer this question. There is a question I think similar to that at the end of the session today. So by the way, you can mention the answer in the comment below right now, okay. So if we put a complete dipole inside a single sphere, what will happen? Also, what will be the electric flux through the outer sphere? What will be the electric flux through the outer sphere? These two are very interesting question. Try to answer that. Now let's see one more question from 2025. So 2025 paper was relatively easier. Charges are uniformly spread on the surface of a conducting sphere. The electric field from the center of the sphere to a point outside the sphere. So we have a charged sphere, we have a charged conducting sphere. So what is the meaning of that? If you give a charge to a conducting sphere, I have discussed during my lecture. If you have missed that, you can go and check that out. So the charges will stay on the surface of the sphere. So you can see that in 2025 3 questions, all 3 are basically from Gauss law portion of the chapter, right? All 3 questions so far are from Gauss law portion of the chapter. So all the charges will stay on the surface of the sphere, and if you find the electric field inside the sphere will be 0. Electric field inside the sphere will be 0. Outside the sphere it will decrease with 1 by r, right? It will vary 1 by r square, sorry. It will vary as 1 by r square. So if you see that here the electric field is 0 and then it is suddenly decreasing with 1 by r square. So correct answer is option 4, because no other diagram has E completely 0 up to the radius. So this dotted line means this is the radius of the sphere. This is the radius of the sphere, okay, capital R. This dotted line represents the capital R of the sphere, right? Here it is a random graph, here it is a random graph, okay, starting from some value and going to 0, which is not correct. Here it may be correct but not for electric field because it is not a straight line, okay, and also some portion is 0, some portion is suddenly it is starting. Here it is correct. So up to this point electric field is 0 and then suddenly it is increasing and then going to 0 slowly. Now next question, which of the following is a correct statement? Another question, and another question from Gauss law. Gauss law is not applicable when charges are not symmetrically distributed over a closed surface. So first of all you have to find the correct statement. That means 3 of them are incorrect, 1 is correct. So Gauss's law is not applicable, is incorrect. Gauss's law is applicable for all type of surfaces. It does not have need to be symmetrical. For symmetrical surfaces it is easier to apply, but Gauss's law can be applied to not symmetrical surfaces as well. Gauss's law law does not hold good for a charge situated outside the Gaussian surface. Gauss's law holds very well even for the charge located outside, because it only considers charge inside. If it is outside, it does not matter whatever is the charge outside the surface, so it is still valid, right? Gauss's law is true for any closed surface. Yes, this is our apparent correct answer. Let's check the fourth option. Gauss's law is true for any open surface. No, Gauss's law is not valid for open surfaces. Gauss's law is only valid for closed surfaces, right? So option 3 is correct answer. Okay, so this is the correct answer. So while answering such wrong or false or correct statement, if there is correct statement or false statement, you have to read all 4 options, then decide. There is only one of them is correct, so you have to check them first, then you can decide. Now next question. This is from 2024. So 2025, all the questions are over. Now let's see question from 2024. The total electric flux through a closed spherical surface of radius r enclosing an electric dipole of dipole moment 2aq is. So the question that I asked you before, now they are asking you here. Okay, total electric flux through a closed spherical surface having a radius small r, okay, enclosing an electric dipole of dipole moment. So entire dipole is inside 2aq. This is the dipole moment. Okay, so what is the electric flux through it? Now for that, obviously you have to understand the question language is slightly different. So you have to understand what are all the charges. We have plus q and minus q as the charges inside the sphere. So what is the total charge enclosed? What is the total charge enclosed? Total charge enclosed is plus q minus q, that is 0. So if you enclose a dipole inside a spherical surface or any surface, the flux will be always 0. Flux will be always 0. So correct answer is option A, 0. Next question. Under electrostatic condition of a charged conductor, which among the following statement is true? Now this question is partly the next chapter, partly this chapter, because some of the options which are incorrect are actually you can be found, the correct answer can be found in the next chapter. Now first question, first part, the electric field on the surface of a charged conductor is sigma by 2 epsilon naught. It is not correct. For a charged conductor, the electric field near the charged conductor is sigma by epsilon naught. The derivation used to be the part of the syllabus. It is no longer there. So it will be sigma by epsilon naught. The electric potential inside a charged conductor is always 0. So for example, this is an part that you will learn in the next chapter. Electric potential inside a charged conductor is constant. It not necessarily to be 0. If it is charged, then potential is not 0, but it has a constant fixed value. Any excess charge resides on the surface of the conductor. So any excess charge, whenever you add some charges on the sphere or conductor, the charges will no longer stay on the inside the conductor. It will always come to the surface of the conductor. So this is a correct statement. This statement is correct, right? So charges will always stay on the surface of the conductor. Okay, if you give some charges, it will always stay on the surface. So this is the correct statement. So far so good. Let's check the option D as well. Net electric field is tangential to the surface of the conductor. So what is the electric field? If you remember our yesterday's day before yesterday's class, where we are discussing about the electric field. So electric field is this is the tangential plane. Electric field is along the normal. Electric field is along the normal to the tangent or along the area vector. You can say either along the area vector or along the normal. Okay, so it is not correct. It is not tangential. Tangential means electric field has to be in this direction. Okay, whereas this is the direction which is actual direction of electric field. So correct answer is option C. All 3 options are incorrect here. Now, as I have shown you the YouTube result, here are the result of Deeksha offline campuses. As you can see, this is only engineering ranking. Ketan, Trupti and all Sanmit, they all did an excellent job, and our in-house campus result is very good. And this is only KCET. We have JEE result as well, NEET result as well. So all the results are super good. And if you want to be part of this excellent to be taught by excellent teachers, and if you want your results to be excellent, don't forget to check out on the number given in the description and contact us so that we can call you back. Right, now let's move on. Uniform electric field E equals to 3 into 10 to the power of 5 Newton per coulomb is acting along the positive y axis. Okay, so electric field is acting, this is x, say this is x axis, this is y axis. Electric field of 3 into 10 to the power of 5 acting along the y direction. Okay, electric flask through a rectangle of area 10 centimeter into 30 centimeter whose plane is parallel to zx plane. So what is zx plane? So this is x. Okay, suppose x cross y, so this is z. Okay, this is z axis. So zx plane means this plane. Any plane which is parallel to this is called zx plane. Okay, so what is the electric flask through this? Okay, what is the flask? Now flask is, what is the formula? E dot dA, or if dA is regular, then we just write E dot A, or EA cos theta. Right, now in this case, what is the angle theta? So this is the direction of electric field, this is the direction of the surface. So if this is, they are in the same direction, so theta is 0. Theta 0 means cos theta is 1. So flask will be E into A. EA Sports, right? FIFA, how many of you play FIFA? So electric field is given 3 into 10 to the power of 5. And what is the area? Now be careful, here area is given in centimeters into centimeters. So 10 into 10 to the power of minus 2 meters into 30 into 10 to the power of minus 2 meters. So both centimeters must be converted into meters so that you don't get the wrong answer. Now let's multiply. So you'll get 3 into 10 into 30, 30 into 30 is 900, 900 into 10 to the power of 1, 5 minus 2 minus 2, so minus 4, 5 minus 4 is 1, or 9 into 10 to the power of 3. Okay, 9 into 10 to the power of 3. Now unit is given in terms of voltmeter. It is same as Newton coulomb per meter square. Newton per coulomb per meter square. Let's see the next question. A body has a charge of minus 3.2 microcoulomb. The number of excess electron it has. Now here it is a question. How to solve it? I have given you a shortcut method. I have also explained the elaborate method. Today I am going to use the shortcut method to answer this question. So I told you 1 coulomb charge is equals to 6.25 into 10 to the power of 18 number of electrons. Okay, 1 coulomb charge means this many number of electrons. So what is the meaning of minus 3.5 microcoulomb minus 3.2 microcoulomb? First of all, 3.2 microcoulomb equals to minus 3.2 into 10 to the power of minus 6. Okay, so this is the charge in coulombs. So what is the number of electrons? So number of electrons will be number of electrons. I'm just writing in shortcut, and here the sign does not matter. Number cannot be negative, right? And you have to multiply with this factor 6.25 into 10 to the power of 18. Practice this. Okay, if you practice this, it will save a lot of time. Okay, this is the easiest shortcut method. So 3 into 6 is 18. Okay, 3 into 6 is 18. There is a 0.25 as well, and there is a 0.2 as well. So the very closest number to that will be 20. Okay, you can, if you don't understand, you can use 18 as well, but then you have to understand which one of them will be correct. But you can see that from the options, there is one more way to check. From the options you can see that 3 options are 5, 5.12, 5, 5.12. But are you getting any number closer to 5? You are not getting any number closer to 5. So what number you are getting closer to? You are getting the number closer to 2, because 20 can be divided by 10 and it can be made into 2, right? So this is possible. So this is how you think. 10 to the power of minus 6, 10 to the power of 18, that is 10 to the power of 12. Now take this 0 over here, you get 2 into 10 to the power of 13. Okay, number of electron is 2 into 10 to the power of 13, that is option C. Next question. A point charge of plus 10 microcoulomb and another point charge B of 20 microcoulomb are kept 1 meter apart in free space. The electrostatic force on A due to B is F1 and the electrostatic force on B due to A is F2. Then what is the relationship? So very easy question. We have two charges, Q1, Q2. It is applying a force on this, say F2. It is applying a force on this, say F1. Then what is the relationship? We know that F1 vector is equal to minus F2 vector from the third law, Newton's third law. Okay, so it will be obviously equal but in the opposite direction. It does not depend on the magnitude of the charges. The force will always be equal and opposite. Electric field at a distance r from an infinitely long uniformly charged straight conductor having linear charge density lambda is E1. So we have a very long charge, infinitely long wire. Electric field at some distance is E1. Okay, distance is r. Okay, another uniformly charged conductor having same linear charge density lambda is bent into a semicircle of radius r. The electric field at its center E2 is. So if you bend a radius r, okay, electric field at the center will also be same. If electric field E1 over here, E2 will be equals to E1. Okay, the derivation I am not doing it, but it will be same as E1, so it will be E1 equals to E2. Correct answer option B. A cubical Gaussian surface has side of length A equals to 10 centimeter. Electric field lines are parallel to x-axis as shown over here. The magnitude of electric field through surface ABCD and EFGH are 6 kilonewton per coulomb and 9 kilonewton per coulomb respectively. Then the total charge enclosed by the cube, take epsilon naught as 9 into 10 to the power of minus 12. So I have solved this question during my lecture and I will repeat it once more. So what is the question over here? Here we have two surfaces ABCD, okay, and EFGH. EFGH. Okay, so here the electric flasks are given and you have to calculate the charge, whatever charge inside this. Okay, so whatever charge Q inside, that we have to find out. First, what is our task? So if you see that it is given that electric fields are given, right, 6 kilonewton per coulomb and 9 kilonewton per coulomb. So first task is to find the whatever is the flask that is coming in, flask in, phi in. So how to calculate that? It is E into A, because electric field and the area vector are in the same direction. So here it will be E into A. So what is the flask in? Flask in is, what is E given? E is 6 kilonewton. Kilo means 10 to the power of 3. Kilo means 1000. Right? What is the area? area is the area of this square. Okay, side given here 10 centimeter. 10 centimeter means 10 into 10 to the power of minus 2 whole square. Okay, so it will be 6 into 10 to the power of 3 into 10 to the power of minus 2. If you remember how I did it, okay, 10 into 10 to the power of minus 2 is 10 to the power of minus 1, and 10 to the power of minus 1 square is 10 to the power of minus 2. So it will be 6 into 10, that is 60. 60 is the phi in. What will be the phi out? Phi out, again, whatever electric field was going out. What is the electric field going out? Going out is 9 kilonewton. 9 into 10 to the power of 3 into area. So it will be 90 units. Okay, Newton per coulomb per meter square. Right. So this is the flask that is going in, that is the flask which is going out. So what is the net flask? Net flask is always phi in minus phi out. That is, what is coming in is 60, going out is 90. So net flask is minus 30. Net flask is minus 30. So what is the charge? So from Gauss's law, net flask is equals to Q enclosed by epsilon naught, or Q enclosed by epsilon naught equals to 30, or Q enclosed equals to 30 into 9 into 10 to the power of minus 12. This is the value of epsilon naught given in the question. So it will be 270 into 10 to the power of minus 12. Okay, or it will be 1, 2, 3, that is 3 decimals. So it will be 0.27 nanocoulomb. Now remember that here this flask was minus, so here also it will be minus. Okay, so the final charge will be also minus. So it will be minus 0.27 nanocoulomb. So minus 0.27 nanocoulomb is the answer. Now next question. A positively charged glass rod is brought near an uncharged metal sphere which is mounted on an insulated stand. If the glass rod is removed, the net charge on the metal sphere is. So here we have a metal sphere which is mounted on some insulated mount, and we brought some glass rod. This is charged. Okay, when this glass rod is close to the sphere, what happens is that the sphere basically gets induced, some part positive, some part negative. But when you remove the glass rod, what happens is that all this negative and positive, they again recombine, so that the net charge inside the sphere remains 0. So it is an isolated system. So as long as the system is isolated, the charge will be conserved. So net charge will still be 0. Net charge will still be 0. Next question. A tiny spherical oil drop. Now this question you can skip it. This is the most difficult question in the history of KCET. Okay, and it came only once, and never this type of question never came more than once. This is the only one exception where this question came. Maybe the teacher who was forming this question was doing it for advanced physics, advanced JEE advanced, but by mistake he has given this question over here. This question is an advanced JEE advanced level question. This is not KCET, not even JEE mains level question. This is a very difficult question, and it requires a lot of concepts from your PU1 as well. But if you are interested, obviously I will solve it. But if you want, you can skip this question, go to the next one. A tiny spherical oil drop carrying a net charge Q is balanced in still air with a vertical uniform electric field of strength 81/7 pi into 10 to the power of 5 volt per meter. when the field is switched off, the drop is observed to fall with a terminal velocity of 2 into 10 to the power of minus 3 meter per second. Here G is 9.8 into 10 to the power 9.8 meter per second square. Viscosity of the air is 1.8 into 10 to the power of minus 5 Newton second per meter square, and the density of the oil is 900 kg per meter cube. The magnitude of the charge Q is. So let us understand first what is happening over here. So here we have a charge Q, okay, and initially it is balanced with using an electric field of this magnitude. Okay, so what is the electric field? Electric field, it is vertically upward. So vertically upward means, so this is the electric field. Now what is the role of electric field over here? What it is doing? So the electric field is applying a force. The electric field is applying a force and the charge is balanced in air. That means how it can be balanced? Because there is a downward force which is mg, the weight of the charge. Okay, but if you read the question, the mass is not given anywhere. Okay, so what is this force, by the way? The force here, the electric force here is Q into E, right? That we know. So this is the force Q into E, and that should be balancing the weight of the sphere or the charge sphere, right? So QE must be equals to mg. Now once you switch off the electric field, what is happening now? The sphere is falling. After some time the sphere is falling with a constant velocity. The sphere is falling with a constant velocity. So that means the sphere has attained the required terminal velocity. Okay, so the sphere has attained the required terminal velocity. So how can a sphere attain a terminal velocity? That means at this point whatever forces are acting on this sphere are again cancelling each other, right? So what are all the forces acting on it? There are two forces. Upward force is the viscous force. Upward force is the viscous force and downward force is obviously mg force. So that means when this is falling using a constant velocity, okay, the viscous force now must be balancing the weight of the sphere or oil drop. Okay, so how it is possible? It is easily possible because viscous force is known as 6 pi eta r v. Here v is the terminal velocity, and that is also equals to mg, right? So we are getting two equations. So mg substitution is okay. This question would have been easier and a KCET level question if they had provided the radius of the oil drop instead of providing this density. This density is actually making this question difficult, nothing else. If the radius is given, you simply compare QE and this 6 pi eta RV and you can solve it like this. Okay, so these concepts are still okay. This much concepts are still okay, solvable. But because of this density, this question becomes very difficult. Not only difficult, it is very difficult. And as you have seen, the values are also not simple. Okay, values are also very complicated. So first what we have to do, first we have to find the radius r and relationship between the charge q. Radius r and charge q. Now how to do that? So it is an oil drop, right? It is an oil drop of some radius, say r, and density rho. Okay, if radius r and density rho is known, then we can even find the mass. Okay, what will be the mass? Mass will be rho into volume. Now what is the volume of a spherical object? Volume of a spherical object is 4/3 pi r cube. So the mass will be 4/3 pi r cube into rho. Now we will use that in this equation first. First we will use it in this equation. Okay, so QE equals to mg, right? Again mg is equals to 6 pi eta rv. No, let me use this equation first, that will be easier. Okay, this equation, let us start with this equation. So 6 pi eta rv equals to mg. Okay, now what is m? M is this 4/3 pi r cube rho. Okay, so from here you can see pi cancels and you get one of the r will be cancelled. So here on the right hand side you are getting r square. So r square equals to 6 eta v divided by 4/3 rho. Okay, r square is already here, 4/3 rho. So here if you cancel it, you will get 9/2 rho v by eta v by rho. So this is the value of r square, right? As you see, this value is not simple. Even if you put the values of eta and v, you will not get a squareable value. That is the main question. I mean another problem. Okay, you will not be able to solve this directly. Even if you think that okay, I will get the answer r from here, I can equate, that is also not possible. Let's see. Let's try to solve another way. I was solving, so far I was solving this question in a different way. Let us try this. 9/2, and then we will decide if we can square it or not. 9/2 eta is given by 1.8 into 10 to the power of minus 5. 1.8 into 10 to the power of minus 5. Then v is 2 into 10 to the power of minus 3. And then we have divided by rho. So rho is 900 kg. So 900 kg. Okay, so let's simplify this. So we get 100, here we get 2 cancels. So here we got 1.8 into 10 to the power of minus 5 minus 3, and then division by 100, we get 10 to the power of minus 10. So as you can see, this is not a squareable number. If this number was squareable, again this problem would have been much easier. Okay, now 1.8 you are thinking 9 into 0.2, but 0.2 square root is very difficult thing. So I am not going into that trap, and I am keeping it as it is here. Okay, so this is the value of r square. Remember, this is the value of r square, not r. Right? Now what we will be using, again QE is equals to mg. QE equals to mg. Again mg equals to 6 pi eta rv. Okay, so we are trying to find what? We are trying to find q, right? So q is equals to 6 pi eta rv divided by e. Okay, now again put the values. 6 pi eta is 1.8 into 10 to the power of minus 5. R value is still not known because it is r square. Don't put this value over here. This is r square. Rv is 2 into 10 to the power of minus 3. And also I think I missed somewhere I missed a g. There was a g over here. That one I missed. Okay, so it will be rho g. Rho g. So here we also had a 9.8. 9.8. I think it can be square root now. We can do the square root. So 18 by 98 into 10 to the power of minus 10. So I have removed the decimals. So it will be 9 by 49. Yes, you can do the square root now. Okay, so here r will be equals to square root of this will be 3 by 7. Yes, so now it becomes much easier. So r square root is possible, so we have found the value of r's finally. So we can put that value over here and the calculation will be slightly easier than whatever I was doing. So it will be 3 by 7 into 10 to the power of minus 5 into V is 2 into 10 to the power of minus 3. Sorry, my mistake. I missed this G, that's why it created a confusion. It can be solved. 81, E value was 81 by 7 pi into 10 to the power of 5. Okay? Right? Now, let's simplify. Pi cancels. Divided by 7 gets cancelled. Okay? Here we get 327, 3 to the 6, 9, 9.2. Okay, so what we got? We got 2 into 0.2 into another 2 into 10 to the power of minus 5. This will also go up and minus 5. So minus 15 minus 18. Okay, so if you take this decimal out, it will be 8 into 10 to the power of minus 19. This is the charge. 8 into 10 to the power of minus 19 coulomb. So answer is this. And trust me, this is the easiest possible solution that I have done. I have solved this question multiple times, but every time I used to forget this thing and I used to compare it, and the solution becomes slightly trickier, but again this is the answer. And today I tried in a different way and I thought, okay, let us try to find out r square, and that's how I realized that okay, it can be squared root and you can still find the value, but still as you can see that process is longer. The space required to solve this question is equivalent to almost 3 to 4 pages of your KCET paper. 3 to 4 pages we will not get because in the KCET paper the space given is very small. Okay, so 3 to 4 pages means you will be not able to solve all the questions properly. That is why this is one of the most difficult question in the history of KCET. Okay, now if you have any doubts, please don't forget to mention that in the comment below. Let's move on. An electric dipole with a dipole moment 4 into 10 to the power of minus 9 coulomb meter. So this is not centimeter, this is coulomb, capital C and small m. Remember that there was a confusion in this year's PUC final board exam as well. They written something like micro cm. Remember that there was a small space left, so student thought micro centimeter. Micro centimeter is not correct, it will be coulomb meter. Okay, remember that in centimeter C and m both are small. If you write capital C small m, it is always coulomb meter. Okay, so unit wise stay vigilant, be careful that capital C means always coulomb. Okay, small c and m means centimeter. Okay, so here we have coulomb meter. Okay, so dipole moment is given 4 into 10 to the power of minus 9. Okay, is aligned at theta equals to 30 degrees. Okay, with the direction of uniform electric field 5 into 10 to the power of 4 Newton per coulomb. The magnitude of the torque acting on it. So what is the magnitude of the torque? Torque is PE sin theta. That is P into E sin theta. Sin 30 is half. Right? Sin 30 is half. So it will be 2 5s are 10. So 10 into 10 to the power of minus 5, that is 10 to the power of minus 4. Okay, so the torque is 10 to the power of minus 4 Newton meter. Okay, next question. 4 charges plus Q plus 2Q plus q and minus 2q are placed at the corners of a square ABCD respectively. The force on the unit positive charge kept at the center O is. So here we have a square. Here we have a square. Okay. So A, B, C, D. Okay, so these are the four corners. So how the charges are placed? Plus q first, plus 2q next, plus q again, and minus 2q. I have not written the plus sign, obviously it is understood. Right? Now it says that what will be the electric force on the unit positive charge. So what will be the electric force on the unit positive charge kept at the center? So center means it is basically at the junction of the cross section of the two diagonals, right? It is the cross section of the two diagonals. So you don't need to find the magnitude, you only need to find the direction. If you read the question, along the diagonal AC is 0, perpendicular along the diagonal BD, so basically you have to find the direction. So first let us try to find what is the force on this plus charge due to this. This is plus, so it will be repulsive force. Now what about this charge? Okay, this is plus, so again it will be a repulsive force. Okay, now both charges are equal, so these two forces will be also equal, so eventually they will cancel each other. Okay, so forces along AC will cancel each other. What about the force due to this? Force due to this will be away from, again this is plus, it will be away from. What about minus 2q? Minus 2q is, this is plus, this is minus, so this will be attractive. So both forces due to plus 2q and minus 2q, they are on the same direction. So if they are on the same direction, they will be added up, and if they added up, what is the net force then? Net force will be along the diagonal BD. It will be along the diagonal BD. So it is along the diagonal BD. Correct answer option D. Next question. A charged particle of mass m and charge small q is released from the rest in an uniform electric field E. Neglecting the effect of the gravity, the kinetic energy of the charged particle after t second is. So this question I have solved during my during my lecture. Okay, again let us solve it once more. So first we have a charged particle, say q. It is given q, and we have an electric field E. Okay, it is kept the charge is kept in this electric field, and then it is released, right? So what is the force acting on this? There will be a force acting on this. So what is the force? Electric force is Q into E. Okay, Q into E is the electric force, right? If Q into E is the electric force, then what is the acceleration? So again, father equals to ma. Father equals to ma. So what is the acceleration? Acceleration is Q into E by m. Q into E divided by m. So what is the velocity after time t? What is the velocity after time? V is equal to u plus at. Now initially it was at rest, so u is 0. A we have calculated QE t by m. So this is the velocity. So velocity is QET by m, right? U was 0. Now what is the kinetic energy? Kinetic energy we know is simple, half m v square, right? So what is the kinetic energy? Half m v square means Q square E square T square by m square, entire thing square, right? So let's organize it. So it will be E square Q square T square by 2m. One of the m's will cancel, right? So E square Q square T square by 2m. So correct answer option C. Next question. An object of mass 2 gram located in a region of uniform electric field E equals to 300 Newton per coulomb carries a charge Q. The object is released from the rest at x equals to 0, has a kinetic energy of 0.12 joule, 0.12 joule at x equals to 0.5 meter. Then Q is almost similar question I'm saying, not same question, but in the previous question Q was given, and in this question you have to find the Q. The only difference is that last time time was given, here distance is given. Okay, so here in this question distance is given, previous question time was given. So what is the formula for that? First of all, we know that from work energy theorem, that is the theorem that you have learned in your first PU, that work done is equals to change in kinetic energy. Change in kinetic energy, and if it is starting from rest, then this will be equals to kinetic energy, because if it is starting from rest, okay, starting from rest. Then whatever is the final kinetic energy, that will be equals to the work done. Now what is the work done? Work done is given by force into displacement. Cos theta is there, but in case they are in the same direction, again we can ignore the cos theta term. So here if you see that the electric field is given, charge say Q. So what is the electric force? Electric force is Q into electric field. So, and what is the displacement? Displacement here is given by x. So you can write this as Q into E into x. Okay, so this is the work done, and that should be equals to the kinetic energy. So what is the kinetic energy? Kinetic energy is given by 0.12. So from here we can write that Q equals to kinetic energy divided by E, electric field E, times x. Okay, so let's put the value. So Q equals to kinetic energy is 0.12. Then we have electric field E as 300 and displacement as 0.5. Okay, so it will be simplify this. You can do it to 0.24 divided by 300, okay, or 3 8s are 24, so 0.08 divided by 100, or it will be 0.8 into 10 to the power of minus 3 coulomb, or it will be 800 microcoulomb. So it will be 800 microcoulomb. Okay, now remember that the electric field is along the x-axis, and the displacement is also in the positive x direction, so charge must be positive. Okay, if it is moving in the opposite direction, then it will be a negative charge. Remember that in case the displacement is positive, the electric field is also in the along the x direction, that's why the charge is positive over here. If the same question was given and said x equals to minus 0.5 meter, okay, then it would be minus 800 microcoulomb. Okay, now next question, electric field due to an infinite straight uniformly charged wire varies with. So electric field due to an uniformly charged wire is 2 lambda by r, if you remember. So here as you can see, the electric field varies 1 upon r. Okay, so this is a special case, it is 1 upon r, not 1 upon r square. Next question, a copper rod AB of length L is rotated about end A with a constant angular velocity omega. the electric field at a distance x from the axis of rotation. Very interesting question. Here we have a rod which is rotating with an angular speed omega. Angular speed omega is given. They asked you what is the electric field at some distance x. Electric field at some distance x. Very interesting question. Nothing else is given, and they asked you, they give you some value of E, they give you mass of electron. Bus. Now how to solve it? Very interesting question. So to do that, what you have to do is, first you have to consider at a distance x, you have to consider an electron E. Okay, so if it is rotating, if the metallic rod is rotating, the electron is also rotating inside the rod, right? All the atoms are also rotating, electron is also rotating. Let us focus on that single electron and say this electron is rotating in a circular path, right? So if someone is rotating in a circular path, then what is to be there? There should be at least one thing. What is that? There should be a centripetal force. For rotational motion, centripetal force is a must. Now for this electron, someone has to provide the centripetal force. If the centripetal force is not provided, the electron will not be able to rotate and the rod will eventually not be able to rotate. So whoever is providing this centripetal force for this electron, if there is an electric field E, then definitely this electric field E is providing the required centripetal force. So what is the centripetal force formula? It is mv square by r, or because omega is given, I can write this as m omega square r. Okay, but here instead of r I will be using this x. Okay, because the distance is given as x, so I'll be using x. So m omega square x, this is the centripetal force, this is the required centripetal force, and who is providing that? That must be providing by the electric force. Centripetal force, remember, I will discuss this in more details when we come across the chapter in first PU. Centripetal force has to be provided by someone. Centripetal force is required for a rotational motion, and the required force has to be provided by someone. If the required centripetal force is not provided, then the rotational motion will not be able to continue. It can be tension, it can be gravity, it can be electric force, it can be any force, but that force has to provide the required centripetal force. This is the required centripetal force. Okay, and the second force who is actually providing this, okay, so this is, you can consider this is the money required to purchase something from the market, that is centripetal force. Okay, and someone has to provide you the money. It can be your friend, it can be your parent, it can be your relative. Okay, you want to buy a chocolate, Cadbury chocolate from the shop. Okay, say the price is 100 rupees. If you don't have 100 rupees, can you buy that chocolate? No, right? So either someone has to provide that money to you. It can be anyone. That does not matter, but someone has to provide that money to you. That's how the centripetal force works, right? So let's see. So what we are trying to find? We are trying to find this electric field E. So E equals to m omega square x divided by E. Even though we had nothing to start, we are still able to find how much electric field will develop when you rotate a rod, a simple rod. Okay, that is still possible, even though it is very, very small. Okay, but there will be an electric field. Next question. When a soap bubble is charged, when you charge a soap bubble, charges will stay on the surface. It's a bubble, right? Nothing is inside, so charges will always stay on the surface. Now these charges, what will they will do? They will repel each other. Similar charges, it can be both positive, it can be negative, but whatever it is, they will always repel. So repulsion means what happens is that the charge will try to stay further and further apart, right? So that means the radius of the sphere will increase. So its radius increases. So option C is correct. Next question, the electric field lines on the left have twice the separation on those on the right as shown. So electric field on the left is twice that on the right. So that means you have to understand that closer the electric field lines, stronger it is. Further they are apart, weaker it is. So electric field near A is, suppose the electric field here is say E. Okay, so the distance between them is say X. Now here they are all further apart and it is 2x. If the distance is 2x, then electric field around here will be half. If you know the relative distances, then generally you can say that if the distance becomes double, then electric field becomes half. Okay, so electric field at A is given. 40 volt per meter. Okay, what is the force on 20 microcoulomb charge kept at B? So what will be the force 20 microcoulomb charge kept at B? So what is the electric field? What is the electric field here? Electric field here will be half of that, that is 40 by 2, that is 20. So this is the electric field at B. Okay. So it will be 20 into 20 microcoulomb. Okay, 20 volt per meter into 20 microcoulomb. So that will be the force. Force is Q into E dash. Here E dash because we are trying to find at E. So what is the charge? Charge is 20 microcoulomb, that is 10 to the power of minus 6, and electric field is 20. So it will be 400 into 10 to the power of minus 6 or 4 into 10 to the power of minus 4. So this is the answer. Option C is correct. Next question. A point charge small q is placed at one corner of a cube as shown. So here we have a point charge. Suppose it is placed at this corner Q. Okay, and what is the electric flux through the face ABCD? What is the electric flux through the surface ABCD? This is also a very interesting question. You might think that because the charge is located at the corner, electric flux will be 0. Actually it is not correct. Okay, even though it is not fully inside, it is not fully outside. So this is a very interesting question. For that, what you have to do is, first you have to understand that what would be the electric flux, if this entire charge was kept inside. If the entire charge is kept inside, what would be the electric flux through this surface? That is very important. So this is a cube. So how many surfaces does a cube have? Cube has 1, 2, 3, 4, 5, 6. 6 surfaces, and the flux through each of them should be equal, right? If it is kept at the center. If the charge is kept at the center, then flux will be same for all the sides. So total electric flux is Q enclosed by epsilon naught. Now for one surface, say ABCD, it will be 1 by 6 Q by epsilon naught. Now this is when the charge is kept at the center. When the charge is kept at the center, right? So this would have been the flask. Now charge is not at the center, so it is kept on the corner. So what we can do? When the charge is kept on the corner, we have to create a system. Such that the charge comes back to the center. How can we do that? For that, we have one sphere over here, one cube over here. We will consider one more cube. So this was our corner, right? This was our corner. So what we will do, we will construct some more cubes, one here, okay, one up, one here, okay, then one on the other side. And if you see, we can construct up to 8 cubes. We can construct up to 8 cubes. Okay, total number of cubes required so that this charge comes at the center. This charge comes at the center. We require 8 cubes. You can imagine for 1, 2, 3 surfaces are there. 1, 2, one on the other side, one on the other side, one on the bottom side, and also the whatever gaps are there, you have to fill them up, and you will see that there are total 8 cubes, including this one. Total 8 cubes are required. Now once 8 cubes are there on the surface, this surface, okay, what would be that surface? That would have, that top surface ABCD will now have 4 squares. Okay, 4 squares. Initially for this 1 cube there is only 1 square. Now for 8 cubes there will be 4 squares, not 8 squares but 4 squares. They will be stacked upon each other. Okay, 1 cube on the top, 1 cube on the bottom, total 8 cubes. This is our ABCD surface. This is our ABCD surface. Through this we are trying to find the electric flask, right? Now for this entire surface, what is the electric flask? Electric flask is 1/6 of the Q by epsilon naught, right? For this entire surface. For this small portion, what will be the electric flask? Now for that, what you have to do, you have to divide this surface into 1/4. This is 1/4, 1/4, 1/4, 1/4. So basically you have to multiply this by 1/4. Okay, so it will be Q by 24 epsilon naught. It is a geometry problem, not a physics, not a super physics question. Physics part ends over here and maybe over here. Rest of the part is basically geometry. Okay, so if you are a little good with the imagination and geometry, you can answer this question. Okay. Now let's move on to the next question. Infinitely long thin straight wire has uniform charge density of 1/4 into 10 to the power of -2 coulomb per meter. What is the magnitude of electric field at a distance 20 centimeter from the axis of the wire? We have a wire and 20 centimeter and we are trying to find what is the electric field. So what is the formula? If you remember, electric field formula was 1/4 pi epsilon naught 2 lambda by r. Now why I told you to remember like this way, now it will be very handy for you, because we know this value as 9 into 10 to the power of 9, right? Now 2 lambda, that's why I use the term 2 lambda for your simplifier. It will help you to simplify the equations quicker and better way. So lambda value is given by 1/4 into 10 to the power of -2. Okay, and the r value, what is the r value? R value is 20 centimeter. 20 centimeter means 20 into 10 to the power of -2. Remember that, always convert centimeter to meter by multiplying 10 to the power of -2. That will take a major problem in your life, that to manage decimals. Do not try to manage decimals, it will be very difficult. Sometimes you have to square it and you will forget one of the point and you will lose marks. So don't try that, keep it simple, convert it into 10 to the powers. That is the most easiest way. Okay, so here we will get 10, so it will be 9/4 into 10 to the power of 8. So this 10 and 10 to the power of 9, I adjusted it over here and I kept 9/4. Now you may not be able to match my speed right now, but if you keep on practicing slowly, it does not come in a day. Okay, you have to keep on practicing, you have to keep on following me, try to understand how sir is doing this fast. So once you are doing this yourself, you will also be able to match my speed. Okay, now 9 by 4 is approximately 2 into 10 to the power of 8. So how I said 10, 2, 9, what is the closest number? Closest even number multiplier of 4 is 8. So 8 by 4 is 2. My problem solving is done. Okay, now I have to check the options. So if you see the options, the closest answer is 2.25. So this is the closest answer. So this will be our answer as well. Now next question, an electric dipole is kept in non-uniform electric field it generally experiences. So I have discussed this concept in my lecture. So electric dipole kept in non-uniform electric field, it generally experiences a torque as well as a force. Okay, a force and a torque both are experienced in non-uniform electric field. If it is uniform electric field, only torque but no force. But here it is a non-uniform field, so it will be force and torque both. The certain charge 2q is divided at first two parts q1 and q2. Later the charges are placed at certain distances. If the force of interaction between the two charges is maximum, then, so we had one charge 2q, we divided into two parts q1 and q2, and we say that the force between them is maximum. Okay, force between them is maximum. Now this is a maxima minima problem. You can try to solve it once you know maxima minima in mathematics, but you have to remember one thing: the force between two charges will be maximum when their magnitudes are equal. Okay, so the magnitudes are equal means this will have q, this will also have q. So when you divide a charge, if you divide them equally, then only the force between them will be maximum. Okay, so if you divide them equally, then only the force between them will be maximum. So q1 by q2 will be q by q, that is 1. So correct answer is option A. Next question, the force of repulsion between two identical positive charges when kept with a separation r in air is F. Half the gap between the two charges is filled by a dielectric slab of dielectric constant 4. Then the new force of repulsion between these two charges becomes. So first of all, we have two charges. So distance between them, say r, and what is the force? Force is 1 by 4 pi epsilon naught q1 q2 by r square. Okay, now if you fill half of it with a dielectric constant k, okay, then what will be the force between them? So there is a trick. I have discussed it, maybe not in detail, that this force, the equivalent distance will be root k into this distance, that is r by 2. Root k into r by 2, and this r by 2 is still there. So what is the total distance? Total distance will be root k into r by 2 plus r by 2. So this is the new distance. So you will use the same formula, but distance will change. Okay, so dielectric constant is given by r, so just put that over here. So r dash equals to root k is 2 into r by 2 plus r by 2, that is 3r by 2. So this is the new distance. Now put the same thing over here. So what is the new force? New force will be 1 by 4 pi epsilon naught Q1 Q2 by 3R by 2 whole square, that is 4 by 9 into F. 4 by 9 into F. So correct answer option D. Okay, again as I said, this kind of how I converted this directly, this kind of aptitude will grow over time. You cannot achieve it in single day. You have to do it using your hand, and once you are doing it, then only you can achieve at this level, right? Also, the PDF of this lecture as usual will be available in our WhatsApp channel. If you have not joined our WhatsApp channel, don't forget to join our WhatsApp channel. The magnitude of point charge due to which the electric field 30 centimeter away has the magnitude 2 Newton per coulomb will be. So magnitude of the magnitude of the point charge due to which the electric field, so E equals to 1 by 4 pi epsilon naught Q by R square. This is the formula. Okay, so you have to find the charge Q here. So Q will be equals to E into R square divided by 1 by 4 pi epsilon naught. Why I am writing it? Because this has a fixed value. So electric field value is given 2 Newton per coulomb, 2 Newton per coulomb into the distance is given 30 centimeters. So as I said, always convert it like this. So your life will be simple and easy. And 1 by 4 pi epsilon naught means 9 into 10 to the power of 9. Okay, now simplify this. It will be 3 into 10 to the power of minus 1. 3 into 10 to the power of minus 1 and then square. So 2 into 9 into 10 to the power of minus 2. So initially what you can do, you can write one more step. You can write one more step over here. And slowly once you are confident enough, you can do it like this. Okay, initially you can write one more step so that you do avoid any confusion. Okay, so 2 into 9 into 10 to the power of minus 2, 9 into 10 to the power of 9. Okay, 9 cancels, you get 2 into 10 to the power of minus 11. 2 into 10 to the power of minus 11 coulomb. Option A is correct. Okay, 3 point charges plus 2q and minus 4q are placed at the corners ABC of an equilateral triangle ABC of the side X. The magnitude of the electric dipole. Now I have solved this question in my lecture, and since it is a little older question, I will not solve it again. But you can check that in my dipole video, that is part 2 of the video, how I solved it, how I made this 2q and this is minus 2q, this is 2q, this is also 2q, okay, and how I have solved this question. Okay, I'm not solving it. This is up to you. It is a task. If you have not watched my part 2 of the video, go and check that out. There I have solved this question in detail. Okay, I have solved some of the questions, but this question I am not solving it. Also, here is a glimpse from our meet and greet session where we have meted all the toppers, whoever were possible to join us on that day. Okay, some of them are here, and if you want us with to take a picture like this, then definitely you have to subscribe to our channel. If you have not yet subscribed, share this channel with your friends so that they can also get help, and once everyone are on the same channel, same area, then you can discuss it among yourself as well, right? So I hope all the best for your KCET 2026 preparation. I'll be back with the JEE PYQs of the same chapter. Till then, bye.